In this section, we're going to begin our study of analytic trigonometry. We'll be looking more in depth at the properties of trigonometric functions. We've already looked a little bit at some of the basic trig identities. Reciprocal identities, we know already that sine and cosecant are reciprocal, so cosecant is 1 over sine and sine is 1 over cosecant. Secant and cosine are reciprocals of each other, and cotangent and tangent are reciprocals of each other. And then we can write tangent as sine over cosine, and because tangent and cotangent are reciprocals, cotangent is cosine theta over sine theta. Let's look at some more identities. If we take a right triangle as part of the unit circle, and here's our right triangle, and this would be theta, and this is cosine, that's our x, which is our cosine, and our sine. Because it's a right triangle on the unit circle, we know that this is going to be radius of 1. So our x squared plus y squared equals the hypotenuse, which is 1 squared, which is 1. Our x squared would be our cosine squared, and our y squared is sine squared. So we're going to come up with a basic identity, which is cosine squared plus sine squared equals 1. And in trigonometry, cosine squared is written like this. So cosine squared theta plus sine squared theta equals 1. And that's a very basic identity. From this identity, we can derive easily two others. If we divide everything in this equation by cosine squared theta, we would get cosine squared divided by cosine squared is 1, plus sine squared theta over cosine squared theta is tan squared of theta, and 1 over cosine squared is going to be secant squared. So 1 plus tangent squared equals secant squared theta. And by the same token, if we divide everything by sine squared of theta, cosine over sine is cotangent squared theta, plus sine squared over sine squared is 1, and 1 over sine squared is cosecant squared of theta. So here we have three fundamental identities. Do you need to remember them all? No, because we know easily how to get them. We do need to remember this one. Cosine squared plus sine squared equals 1, or sine squared theta plus cosine squared equals 1. The order of those does not matter. Let's use these identities to find some of the trig values. We want to find sine and cosine if tangent of theta is 3 and cosine of theta is less than 0. So this is telling you which quadrant it's going to be in. So using the tangent, the identity with tangent is 1 plus tangent squared theta is equal to secant squared theta. Tangent is 3, so we have 1 plus 9, 3 squared is 9, equals secant squared theta. So secant theta squared theta is 10. Secant, we're looking for the cosine. Secant is 1 over the cosine squared theta is going to be 1 over 10. And we want cosine, so this will be root 10 over 10 is cosine squared theta. And cosine's going, sorry, this is cosine, not cosine squared. and because it's less than 0, it's going to be negative. We can do that because when we take the square root, this would have been plus and minus. So we just want the negative. So now we know the tangent, we know the cosine, which is negative 10, root 10 over 10, and we can go right to tangent is sine over cosine, and tangent is 3, so we have sine theta over cosine over negative root 10 over 10. So we're dividing by this, so we want to multiply both sides by negative root 10 over 10. That will cancel out. So sine is going to be negative 3 root 10 over 10. There's our sine, that was our cosine, and we were given the tangent. Pause the video and try this. Find both sine theta and tangent theta if cosine theta is 0.8 and tangent theta is less than 0. Let's take a look at some co-functions. Let's look at angle A here. So if we take the sine of A is the opposite over the hypotenuse, which is y over r. The cosine is the adjacent over the hypotenuse, which is x over r. Now, if we look at sine of B, opposite over hypotenuse, the sine of B is x over r, and the cosine B, y over r, is the cosine of B. Take a look at this. On angle A, the sine is y over r, and on angle B, the cosine is y over r. And for the cosine of A, the cosine of A is x over r, and sine of B is x over r. This is true with each of the functions here, and the complementary angles give co-functions. And if you think about the sine graph and the cosine graph, the only difference between them is where they begin. Sine and cosine both go up and down to -1. So if we take a phase shift from sine, we'll get to cosine. And this is true, again, with each of the cofunction identities. So sine of pi over 2 minus theta will equal cosine. Let's look at some even and odd identities. If we have, let's take pi over 4. If we take sine of negative pi over 4, we'll go down here to negative pi over 4. Sine of pi over 4 is root 2 over 2. Sine of negative pi over 4 is negative root 2 over 2. That's what we have right here. So sine of negative x is the same thing as negative of sine of x, so this is an odd identity. We look at the cosine here in the same manner. We'll take pi over 4. Again, cosine is going to be root 2 over 2. If we take cosine of negative pi over 4, we have not changed the value of cosine. Still going to be regular square root of 2 over 2. So cosine of negative x is equal to cosine of x, so this is an even identity. Now we're going to use some examples of simplifying by factoring and using identities. If we have cosine x to the third plus cosine x sine squared x, we want to simplify this. The first thing that we can do is to factor out a cosine x. And we're left with cosine squared x plus sine squared x. We know that cosine squared plus sine x is equal to 1. So this is cosine x times 1, which is just cosine x. Pause the video and see if you can simplify this one. 1 minus cosine squared theta divided by sine theta. Simplify this one. We have a binomial times a binomial. So cosecant using FOIL, we'll get cosecant squared x. The middle terms will cancel out, minus x over cosine squared x. Cosecant squared x minus 1 was one of our identities. Cosecant squared x minus 1 is equal to cotangent squared of x over cosine squared of x. When you are simplifying and you get stuck, sometimes it's easier if you change everything you can to sine and cosine. So cotangent is going to be cosine squared of x over sine squared of x, still divided by cosine squared of x. So if instead of dividing, if we multiply by the reciprocal, we'll have cosine squared x over sine squared x times 1 over cosine squared x. These will cancel, so this will equal 1 over sine squared of x, and 1 over sine squared by one of our identities is going to be cosecant squared of x. Pause the video and see if you can work out this one. Let's look at solving a trigonometric equation. If we have sine cubed over x over cosine x equals tangent x, the first thing that we want to do is to change this to sine x over cosine x. Now we can multiply both sides by cosine x and cancel that out. So we get sine cubed x is equal to sine of x. So sine cubed x minus sine x is equal to 0. We factor out a sine x. That sine squared x minus 1 is equal to 0. And sine squared x minus 1, so either sine x is equal to 0 or sine squared minus 1 is equal to 0, or sine squared is equal of sine squared of x is equal to 1. So sine squared is going to be 0 at 0 or pi, and sine squared is equal to 1 at pi over 2. Looking back at the original equation, we cannot use this one because at pi over 2, cosine is 0. So this one is not a possibility. So our two answers are 0 and pi. One more for you to try. 2 sine squared x plus 3 sine x plus 1 is equal to 0. Solve it by factoring and find all the values of x in the interval between 0 and 2 pi. And now, just for fun, remember the Romans didn't find algebra very challenging because x was always 10. See you in class.